Hello everyone. Previously, we have implemented post classification into depressed post and non-depressed post using logistic regression and multinomial naive Bayes. And today, let's see how we can do it using KNN. KNN stands for K nearest neighbor algorithm, and it is a supervised machine learning algorithm which can be used for classification tasks as well as regression tasks. And the target value can either be a categorical data or numerical data. And it is a non-parametric and lazy learning algorithm, which means it doesn't make assumptions about the underlying data distribution, and it doesn't learn a model during the training. Instead, it memorizes the training dataset and then predicts. And let us see with an example how KNN works. Let's see. Uh, let this be the training data, and these are already classified into class 1 and class 2. And there is another new test data or a new class which we have to predict, and this value is predicted based on the k value. It takes the k nearest classes or nearest neighbors to it, and based on that, if it is a classification algorithm, as it's here, it takes the majority and classifies itself into class 2. And usually in a regression task, it the target value is assigned based on the average of the k nearest values. And here the distance measured is usually done by using Euclidean distance method. We can also use other distance calculating methods. The main parameters here are k, which is the number of neighbors to consider uh, to make the predictions, and of course the distance metric, it is either Euclidean or Manhattan or anything else. And KNN's decision boundary can be complex and non-linear, which makes it suitable for various types of data sets. The advantage of using KNN is it is simple, there's no training phase, and it can adapt to changes in the dataset. The main disadvantage here is it is computationally expensive for large datasets, and it is sensitive to irrelevant features, so might be influenced by the scale of its features. Unlike the previous projects that we have seen, I have implemented KNN from scratch. So let us understand the code and how it works. So I've taken the same data sets that we have previously used, the Reddit Combi dataset, the Twitter full, and the Twitter non-advert dataset. And I've dropped the all the irrelevant columns and combined these three datasets. And then I've dropped the null values for the data, and I've cleaned the data set, and then split the data into the test and train data sets, and then also I've transformed the data using TF-IDF vectorizer. Here I've implemented the KNN classifier, and in the KNN class we have initialized with the number of neighbors k that is set to 3 by default. And in the fit method, that is where we are training, we are training the data, xtrain features and ytrain as the labels, and store them in the class instance. Next is the predict method, which takes a set of test data and predicts the class labels for each data point using the predict method. The predict method calculates the distance between the input data point x and all the training data points. If the training data is sparse, it converts it into the dense array. It then defines the k nearest neighbors and retrieves their labels and predicts the class label by selecting the majority of the k neighbor classes. And here for our data, I've taken the k value as 5 and then fit the data and then made the predictions. Here are the predictions, and also I've calculated the accuracy, which turned out to be 85%, which is a bit less than the other two models. But uh, if we use we can fine tune the hyperparameter k, and also if we use the inbuilt method, it might result in the higher accuracy. Thank you.